Good evening, everyone. I welcome you all again to the Day 3, Session 2 of Faculty Development Program for Science Educators organized by Shikshan Bharti Vidya Bhavan. And I'm again grateful to Dr. A.K. Sharma sir for providing this opportunity. In the current session, we'll be discussing about the IUPAC nomenclature for grade 10. And before starting with the session, I have a question here. Do we all believe in equal opportunities for all? Yes, dear educators, kindly respond. Do we believe in the equal opportunities for all? You can use the chat box for your responses. Any response? Say yes or no. Okay, fine. If we look at this slide, one is the equity of opportunities, another is the equality of opportunities. Normally we talk in terms of equality, but now there is need to transform from equality to equity of opportunities. And the difference between the equality and equity, this picture is, I think, self-explanatory. Fair is not always equal. Teaching is like doctoring. As you can see on this slide, the kids go to the doctor with the different needs. One says, I scraped my knee. Other says, my stomach hurts. Another one, I think my arm is broken. Then I have a cough. And what if the doctor said the same thing to all of them? Here's some cough medicine. Only one kid would get what he needs. And that's not fair. It's the same thing in the classrooms. Every student has a different needs. One says, I have trouble focusing for more than 15 minutes. Another says, I think better when my hands are busy. Another says, I can talk about what I know better than I can write about it. And still another says, I can't grip a pen or a pencil. So the different students with the different abilities and their different needs. And so the different students should get the different things to help them succeed. As a one who says, I have trouble focusing for more than 15 minutes, break down the test to the shorter ones. One says, I think better when my hands are busy, use up fidget toys and tactile activities. Another says, I can talk about what I know better than I can write about. Then we can go for creating a video instead of composing a paper. I can't grip a pen or pencil. Modified writing stencils can be used. And that's what makes a classroom fair for everyone. That's make our classrooms inclusive. As sir has already discussed the inclusive education with you, if we cater to the needs of all the diverse learners, only then we can say that our classrooms are inclusive. As UNESCO says, inclusive education must recognize and respond to the diverse needs of their learners by accommodating both different styles and different rates of learning and ensuring quality education to all through appropriate curricula, organizational arrangements, teaching strategies, resource use, and partnerships with the community. And we can also go for the differentiated instructions. It's a known fact that no two children are same. Each child learns and processes information differently. So it's a responsibility of the teachers to help the students succeed regardless of these differences. Teachers must structure and tailor their lessons aligned with the skills and the needs of the students. That is, they should follow the differentiated instruction. This is an integral component of inclusive education. And these are the few suggestive instructional strategies for inclusion, that is need based HOTS and LOTS questions, as Sir has already discussed in Bloom's taxonomy. High order thinking skill questions, low order thinking skill questions to be given to the diverse learners, lesson summaries, remedial sessions, peer teaching, project based learning, collaboration, use of ICT, art integration, multisensory instructions. And in the current session, an endeavor will be made to discuss the questions of varied levels to cater to the needs of all the diverse learners. So, starting with IUPAC system of naming, the IUPAC, that is the International Union of Pure and Applied Chemistry, is an international body working for the advancement of the chemical sciences, especially by developing nomenclature and terminology. IUPAC is registered in Switzerland, and the administrative office, known as IUPAC Secretariat, is in the Research Triangle Park, North Carolina, US. IUPAC was established in 1919, but the need for an international standard for chemistry was first addressed in 1860 by a committee headed by the German scientist Frederick August Kickue. Coming to the aim for IUPAC system of naming, each and every object in this universe is identified by its name. When organic chemistry was in its infancy and not much many compounds were known, the compounds were named based on their sources or the name of their discoverers. These names, they are called common or trivial names. The necessity for such a systematic approach arose due to the sheer quantity of the new discoveries of organic compounds, which made the trivial nomenclature of organic compounds highly inconvenient. The goal of IUPAC is to unite the worldwide community of chemists. The aim of IUPAC nomenclature is to create an international standard for designating the compounds to promote the communication. The purpose of the system is to give a unique and unambiguous name to each structure. It provides a common, universally accepted language for chemistry and advocates for the free exchange of scientific information which facilitate the research. A set of rules formulated by IUPAC for systematic nomenclature of organic compounds are given, which are revised from time to time. The trivial names, they are also of high importance, as the compounds named via their trivial nomenclature often have the much shorter and simpler names. As an example, an acid present in the tamarind, that is tartaric acid, it's commonly known as tartaric acid, but its IUPAC name is quite the long and difficult to recall. That's 2,3-dihydroxy-1,4-butane dioic acid. Do you know how many alphabets are present in the largest IUPAC name? How many alphabets are present in the largest IUPAC name? Any random guess from your side? Maybe 50 alphabets, 100 alphabets, 200, 500, 1000, 2000. Any random guess? Kindly do respond. Dear educators, CBSE as well as NEP 2020 advocates the competency-based education with the aim to develop the skills and competencies among the learners, and this really required the active participation of the learners in the teaching learning process. If we as educators are not ready to involve ourselves, how can we motivate our students for the same? So kindly respond for any random guess. What do you think? May it be 50 alphabets, 100 alphabets, or 1000 alphabets, or more than that? Here's the final information. The largest known protein, that's titin, and has the longest IUPAC chemical name written in full. It contains surprisingly 1,89,819 letters. Yes, there's a response in the chat box also with the same figure. It's 1,89,819 letters. They are present in the largest IUPAC name, and its trivial name is Titin. There are certain drawbacks for the trivial names. There are several trivial names. They can exist for one specific compound. As an example, phenol is also known as carbolic acid or hydroxybenzene. And if we know the same compound with the different names at the different places, it will be difficult to communicate globally. As we need the global English language for communication, there must be a globally accepted language for the subject also. That trivial nomenclature system is limited to only a few compounds in each specific group. An example of this is the first members of the carboxylic acid groups. They have the trivial names like formic acid, acetic acid, but no trivial names are there for the carboxylic acids with greater number of atoms. There exists no particular set of guidelines for the nomenclature of the complex compounds in the trivial system. Now, when we start with the organic chemistry, we start with an organic compound. It's a compound of the carbon bonded with other carbon atoms or with some other atoms by the covalent bonds. That carbon is tetravalent. It's tetrahedrally surrounded by 4 bonds. But how do we represent the tetrahedral structure of carbon? As we all teach in our classes, that carbon is tetravalent. It forms 4 covalent bonds. Carbon is tetrahedrally surrounded by the 4 bonds. How do we represent the tetrahedral structure of carbon? Yes, dear educators, anyone who want to explain how can we represent a tetrahedral structure?
We can represent with the help of balls and sticks.
Yeah, we normally use the balls and sticks to represent, as you can see here on the screen in the 3D view also. The ball and stick model is there, or normally while drawing the tetrahedral structure or specifically for methane, what we do, 1 bond on the upper side and 3 bonds on the lower side, or at the most we can use a 3D figure with a stick or a ball. But my dear friends, this type of figures, they don't reflect the clear concept of a tetrahedral structure as required to develop the competences among the learners. Let us see a tetrahedral structure from an entirely different perspective. Now we'll see a tetrahedral structure in a cubic system. Consider a cubic system. In a cube, there are 6 faces. Like if we consider a room to be a cubic room, the 4 walls, 1 floor and 1 ceiling. A total of 6 faces are there. We can say aage, piche, right, left, upar, niche. A total of 6 faces are there, and on each face, there are 2 diagonals. As 2 diagonals, they are shown here in the cubic system at the top. On the ceiling, 2 face diagonals are there. And on 6 faces, a total of 12 face diagonals will be there. Now, these 8 corners of the cube, they are labeled as 1 to 8. Number 1, 2, 3, 4, they are representing the ceiling of the room. Number 5, 6, 7, and 8, they are representing the floor of the room. And the rest, the 4 walls. On the top, there are 2 face diagonals. One represented by number 1 and 3, and another represented by number 2 and 4. 2 face diagonals on the top, I repeat, 1, 3 and 2, 4. And similarly, there will be 2 face diagonals at the bottom, that is 6, 8 and 5, 7. And see, Out of the two face diagonals at the top and two face diagonals at the bottom, I have drawn only one each. At the top, 1, 3 is occupied, whereas 2, 4 is vacant. If we see at the floor, parallel to 1, 3 is 6, 8. And the diagonal which is parallel to 1, 3 on the floor, that is 6, 8 is kept vacant, whereas the opposite to that, 5, 7 is occupied. So two opposite phases with two opposite diagonals. We are not to consider their parallel diagonals. We are to consider the opposite diagonals of the opposite phases represented by the diagonally opposite corners 1, 3, 5, and 7 on this system as shown in the given slide. Now, on these 4 points, that is 1, 3, 5, and 7, these 4, say, atoms, they have been placed. The yellow balls, they are representing the atoms in this case. And see in the middle of the cube, which is also the body center of the cube, another carbon atom is there. These 4 balls are occupying the position 1, 3, 5, and 7. And this can be seen in another way, that these are the alternate corners of the cube. Alternate corners are occupied and alternate are vacant. As 1 is occupied, 2 is vacant, 3 is occupied, 4 vacant, 5 occupied, 6 vacant, 7 occupied, 8 vacant. 4 alternate corners are occupied and 4 alternate corners are vacant. Now, when the carbon present at the body center of this cubic system, when it formed the bond with these 4 atoms placed at position number 1, 3, 5, and 7, this represents a tetrahedral structure in a cubic system. Now, this carbon at the body center of this cube is tetrahedrally surrounded by the balls or the atoms at points number 1, 3, 5, and 7. And here we need to clear one more point to our students, that the bonds are represented by here the yellow lines only. The black lines, the dotted lines, they have no significance for the structure, for the tetrahedral structure itself. Tetrahedral structure is represented only by the yellow lines, and these black lines, they are representing only the cubic system, and these are not the bonds to be represented there. Bonds are only the yellow lines. And this cubic system, it can very easily be shown in the classroom itself, as I'll try to show it to you live. First, you just see this image. In this image, see a two-dimensional cross is getting converted to three-dimensional. When we twist the two limbs of the cross, then the 4 limbs of the twisted cross pointing in the diagonally opposite corners of a cubic system. Now, if we consider these 4 bonds, if we consider these 4 bonds in this position, they are representing a 2D figure. It's simply a cross or a plus sign with bond angles 90 degrees. And this is a 2D figure. If we twist the cross, अगर हम इस क्रॉस की टांग मरोड़ देते हैं, यहां से 2 पॉइंट्स को आगे पीछे ट्विस्ट कर देते हैं, then we can see that these 2 balls, they are pointing on the diagonally opposite corners on the ceiling, and these 2 are pointing on the diagonally opposite corners on the floor, and this is a tetrahedral structure. And why we draw it like 1 bond on the upper side and 3 on the lower side, and see this position. It's the same position that we draw it in 2D, showing 1 bond on the upper side and 3 on the lower. So what we need to do, just take a cross, a 2D figure with 90-degree bond angle, और उस क्रॉस की टांग मरोड़ दीजिए. That's it. And you will get a tetrahedral, and with 4 corners pointing on the diagonally opposite corners of a cubic system. Now, another point. When we draw the structures for the IUPAC system of naming, the carbon chain is represented by a zigzag structure. Zigzag lines are shown to show the carbon chain. Why carbon chain is represented by a zigzag structure? Anyone? Why carbon chain is represented by the zigzag structure? As in the carbon chain,
Ma'am, to show the connectivity of carbon atoms.
yeah, to show the connectivity of the carbon atoms, that's absolutely correct. But why zigzag only? Why not some other shape? What's the significance of this bent zigzag structure?
It is the arrangement of the bonds and the bond angles.
Yeah. Like here, you can see a tetrahedral structure. Carbon is surrounded with 4 bonds. In this zigzag structure, carbon chain, we don't represent the hydrogen atoms. And if from this tetrahedral structure, if you remove any 2 balls, why I'm saying any 2 balls? Because in tetrahedral structure, all the 4 positions are equivalent. All the bond angles are same, that is 109 degrees and 28 minutes. And as all the 4 positions are equivalent, then from this structure, if you remove any 2 balls which are representing the hydrogen atoms, then what we are left with? That's a bent V shape. That's why the carbon chain is represented in a zigzag structure, as it is representing only the bond with carbon atoms, and H atoms are not shown in this line structure. Now, when coming to naming the organic compounds, and after teaching the topic in the classroom itself, what happens when you put a question, write the IUPAC name of the following compound? The major blunder that students they do start with the name as a whole. Instead of starting writing the name as a whole, first of all, we need to break the name into different subparts. Like here, for any organic name, we are to see it in 5 different subparts. The first one to be focused is the root word. That is in the middle of this name, that is root word. And to this root word, there are 2 suffix and 2 prefixes, or we can say 1 prefix and 1 infix. The first word to be focused here is the root word, which is in the middle of any name. And this root word, it depends upon the longest carbon chain. And as we represent meth for 1, it for 2, prop for 3, but for 4, pent for 5, and so on. That is depending upon the number of carbon atoms. Then the second essential part that we have to look is the primary suffix. And this primary suffix means what type of the bonds are present in the carbon-carbon chain. If only the single bonds are there, then the suffix used is "ane". If one double bond, then the suffix is "ene". For the triple bond, it is "ine". Then we go for the secondary suffix. Secondary suffix that represent the different functional groups. So starting with root word, then the primary suffix "ane", "ene", "ine", the secondary suffix functional group, and then we switch over to the prefix. The first prefix, or it is also sometimes named as infix, it is cyclo if the compound is a ring-shaped compound, or nothing is mentioned if it is a straight shape. And prefix to that are written the substituents in the alphabet order. Whatever doesn't come under the root word or the functional group is in the prefix as substituents, and if more than one substituents are present, then they are written in alphabet order. And as here, if we consider these 5 subparts, the 2 subparts, that is the root word and primary suffix, they are the essential parts. Without the root word, that is it, meth, prop, no organic compound is possible, as it represents the number of carbon atoms in the chain. And then without mentioning whether it is "ane", "ene", or "ine", again no name is possible. These 2 are the essential parts. The rest of the 3 are optional. Like a compound may have a functional group, may not have a functional group. It may be cyclic, it may be open chain. If it is open chain, then infix is not mentioned. It may have the substituents, may not have the substituents. So the essential parts are two, that is root word and primary suffix, and the rest of the three are the optional subparts. For the primary suffix, as I have already discussed, N for the single bonds, in for the double, ein for the triple. If two double bonds are there, then di-ene, three double bonds, tri-ene, two triple bonds, di-ene, or if double and triple bonds they come together, then "-ene" is written first, followed by "ein". Here last in the row, you can see "en", "yne", and "e" is omitted. It is "een" plus "ein". The middle "e" is omitted while writing "een" and "ein" collectively for double and triple bond. "En" for the double and "ein" for the triple bond. Then as for the prefixes, the commonly used prefixes methyl and ethyl, one carbon atom, meth se methyl, eth se ethyl. For propyl, two isomers are there, N-propyl and isopropyl. If propyl, that is a chain of three carbon atoms, is bonded from the terminal carbon atom with the parent chain or the main chain, then it is N-propyl. N is for normal. Normal means the straight chain, or it is written as prop1-yl. It is bonded to carbon number 1. Similarly, isopropyl, when a chain of three carbon atoms is bonded through the middle carbon atom. सो मेथ के लिए एक ही ऑप्शन है, इथ के लिए भी एक ही ऑप्शन है. फॉर प्रोपाइल देयर आर टू ऑप्शंस. इट कैन बी एन प्रोपाइल, इट कैन बी आइसोप्रोपाइल. Similarly for but, that is a chain of four carbon atoms. Four options can be there. Four isomeric structures are there: n-butyl, secondary butyl, isobutyl, and tertiary butyl. In n-butyl, bonding is through the terminal carbon. In secondary butyl, bonding is through the middle carbon, that is carbon at position number 2. In isobutyl, there's a straight chain of three carbon atoms. Fourth one is branched on the middle carbon, and bonding is through terminal carbon. Similarly, in case of tertiary butyl, again there's a chain of three carbon atoms. Fourth carbon is branched on the middle, but in this case, the bonding is through the middle carbon. See the difference between isobutyl and tertiary butyl. In both the cases, it's a carbon chain of three carbon atoms. Fourth one is branched on the middle carbon. In isobutyl, the bonding is from the terminal position, and in tertiary butyl, the bonding with the parent chain is through the middle carbon. These are the generally used prefixes, that is for the substituents to be written on the extreme left-hand side of any name. Then these are the certain secondary suffix, which are the functional groups which are there in the syllabus of class 10. OL for alcohol, AL for aldehyde, ON for ketones, Oic acid for carboxylic acid. And this is the extended list with some more options for the functional groups. Now coming to the subparts of this thing, as you can see here, it's a chain of four carbon atoms. The principal chain with four carbon atoms, and the root word which is written in the middle for four carbon atoms, it is written as but. After root word coming towards the right, the primary suffix, it should be "en", "een", or "ein". As in this carbon chain, all are the single bonds, so the primary suffix is "en". Then again towards right, we'll see the functional group. The functional group is on, that's OH. And for OH, alcoholic functional group, the suffix used is OL. Then the functional group OH and four carbon atoms in the chain. If we leave these, we are left with one methyl group outside that chain, which is shown here with a circle. That methyl group is neither counted in the parent chain in the root word nor in the secondary suffix that is in the functional group. So this will go in the prefix as a substituent. As it is with one carbon atom from meth, it is written as methyl. So root word is but, primary suffix is ane, secondary suffix is ol, prefix is methyl. There is no infix because it is an open chain compound. Infix is only for the cyclic compounds, only the cyclo is written here. And if we combine this name, it becomes 3-methyl-butane-2-ol, but care must be taken while writing butane-2-ol. This E of ane, as I've shown here in the red box, when we combine this, E is to be omitted. As the last word of ane is E, and the first alphabet of ol is O, and when two vowels come together, one of the vowel to be omitted. So this grammatic mistake is to be taken care while writing the organic naming. It is ane plus ol. This E is to be omitted, and in 3-methyl-butane-2-ol, butane is to be written without E. It is never with E. As for the numbering of this chain, we can number this chain either from the right or from the left. But the preference to be given to the functional group, as functional group is on position number 2 if we count it from the right side. It is at position number 3 if we count it from the left side. So numbering is to be done from the right side, so that ol is at position number 2 and methyl is at position number 3. This is a list of the different alkenes, and in all these alkenes, a double bond has been shown only at position number 1. So 1 is written in the middle of all these, first root word, and then ene. In the middle is written the position number 1 for enes. It's for eth, prop, but, pent, hex, hept, for number of carbon atoms 2, 3, 4, 5, 6, 7, and so on. Coming to the rules for writing the names. First, we are to select the longest possible chain of carbon atoms. That's a main chain, the principal chain, or the parent chain that decide the root word, that is the middle part of any name. Double and triple bonds are the functional groups if present. They must be the part of the parent chain, even if we may have to select the shorter chain. Like here, the second rule that rules out the first rule. What's the first rule? That the longest possible chain to be considered. But if in the longest possible chain, the double bond or functional group or the triple bond, they are present in the compound, but they are not present in the longest chain, then we will not consider the longest chain. We may have to consider the shorter chain, even though the number of carbon atoms in the other chain are more, but we are to consider the chain with preferred groups, that is functional group, double or triple bond. They must be present in the main chain as far as possible. And while numbering, the order of preference is functional group is preferred over double bond is preferred over triple bond, and triple bond is preferred over substituents. Like if the functional group is present in any name, then the numbering will be start from the side from where the functional group gets the lowest number. If functional group is not there, or from the two sides of the chain functional group get the same number, then the next preference is given to the double bond. If double bond is not there, then next preference is to the triple bond, and then finally to the substituents. Now in this case, as here a compound is shown with a chain of 6 carbon atoms. On these 6 carbon atoms in the chain, which are in the shaded line, 2 methyl groups are outside this parent chain. And these 2 methyl groups, they will be written in the prefix as substituents. And hence the root word in this case is hex plus ane, and no functional group is there, no secondary suffix will be there. In the prefix, first prefix or infix will not be there, but prefix to that are the 2 substituents. They are written as dimethyl, and the position for that dimethyl will be 3, 3. As here, if we number it from the top, then methyl groups are at position number 3, If we number it from the left, then the methyl groups are at position number 4. So 3, 3 is preferred over 4, 4. Now, in this type of the compound where normally the students they commit a mistake, as in the first structure you can say it is written as C2H5. Before writing the name, C2H5 is to be expanded to CH2CH3 as it is shown in the structure number 2 or in the 3. In the first, it is C2H5 and normally students they count it as 1 and they take a chain of 4 carbon atoms. It's not a chain of 4 carbon atoms, it's a chain of 6 carbon atoms. Another mistake that students they normally commit, like here you can see the straight chain is showing the 4 carbon atoms at the top. But if we bend the chain, then the number of carbon atoms they come out to be 6. The chain can be, it's 7 in that case. The chain can be bent. It's not essential that we are to take the carbon atoms along the straight chain only. Then in this structure, there are 3 chains of equal length. All the chains, they have been shaded in pink. And these chains, they are of 7 carbon atoms each. But the chain with more number of substituents is preferred over the other. In the first case, there are 2 substituents only, which are circled. In the first compound, the 2 substituents which are circled, the lower one is with 1 carbon atom, that is methyl, and the upper one is butyl. And as it is butyl bonded with its middle carbon atom, it is secondary butyl. We take a chain of 7 carbon atoms, 2 substituents, one is butyl, another is methyl. If we see the same structure, in the second case, we have changed here the selection of the parent chain. And in this case, 3 substituents are there. At the top on the left side, the substituent is with 1 carbon atom, that is methyl. In the middle on the right, it is propyl. And then towards the lower end, it is methyl. Then in the third structure, same structure in the third case, again the parent chain selection is different and it is again showing the 2 substituents. If the parent chain length is same in the different possibilities, then the chain with maximum number of substituents, that is a second in this case, is to be the preferred chain. And so finally this compound is a heptane derivative. Root word is hept plus ane, and in the prefix the substituents are dimethyl at position number 3, 5 and propyl at position number 4. Coming to the next example, here are the 2 chains with 6 carbon atoms each. But the chain with the double bond as shown in the second diagram is to be selected as the parent chain. In the first case, the chain is with 6 carbon atoms, but the double bond is out of the parent chain. In the second case, the chain of 6 carbon atoms and double bond is inside the parent chain. So second is a correct selection. The first one is the wrong selection. The next example. The functional groups, multiple bonds, that means the double or single bonds, if present, they must be the part of the selected parent chain, even though it contains the less number of carbon atoms than any other chain without the main functional group or double or the triple bonds. So here, the chain again, which is shaded in the first case, it is with 6 carbon atoms, numbered 1 to 6 from left to right. It includes the OH functional group in the parent chain. But if we look at the second structure, in the second structure, the longest chain is with 7 carbon atoms. Although the 7 carbon atoms that form the longer chain, but in that chain, OH is not a part of the principal chain or the parent chain. So this is not to be selected as a main parent chain. The first one with the shorter chain is a correct selection. Now coming to the next rule. When more than one substituents are present, then the series which contain the lowest number of the occasions of the first difference is preferred. Like if we number this chain as in the first case from left to right from 1 to 10, then the three substituents are present at position number 3, 4 and 9. In the second case, if we number this chain from right to left, then the three substituents, they get the position number 2, 7 and 8. One is 3, 4 and 9 and the second set is 2, 7 and 8. So 2, 7, 8 set is preferred over 3, 4, 9. That's the first point of difference. In another similar example, if we number it from the left side, then the substituents are present at position number 2 and 5. If we number it from the right side, like 7 to 1, if we take 1 on the extreme right hand side and 7 on the extreme left side, then the positions will be 3 and 6. 2, 5 is a correct option and 3, 6 is the incorrect, so that it forms 5-ethyl 2-methyl heptane. Another point. Now, in this case, the positions are same on the two sides. The two structures which are shown here, the position of the substituents is same from the two sides. In the first case, it is numbered from 1 to 8 from left to right. First substituent comes at 4 and second substituent comes at 5. And in the second case, if we number it from right to left, again the first substituent comes at 4 and the second substituent comes at 5. So if we number it from right to left or from left to right, the locations are 4 and 5 in both the cases. Now what is to be done in that case? If the locations are same, then we are to consider the alphabet order. The group which comes alphabetically first, that get the lower number. And alphabet order is to be decided on the basis of their names, not according to their symbols. As if one of the substituent is, say, NH2 as amino group in the prefix, we are not to consider its nitrogen as a symbol, amino A consider correct. So here, one of the group is methyl and another is ethyl. They both are getting position 4, 5 or 5, 4. Then the one which comes alphabetically first should get the lower number. That means ethyl should get the lower number, that is number 4, and methyl should get the number 5. But this alphabet order is to be considered only if the locations are same from the two sides. If the locations from the two sides are different, then we are to go for the first point of difference rule. Now coming to the functional groups numbering again. In this case, the double bond is on the terminal position and OH is in between the chain. If this chain is numbered from left to right, from 1 to 8, then OH is at position number 4 and double bond is at position number 1. And the other way of numbering it, it can be numbered from right to left with 1 on the extreme right and 8 on the extreme left. Now the double bond is at position number 8, but functional group is at position number 4. No doubt, in the second case, the double bond acquires the larger number. From the first case, it is between 1 and 2. That is position number 1 is allotted. In the second case, it is between 7 and 8. And double bond is at position number 7. But functional group is preferred over double bond. As in the first case, functional group is at position number 5. And in the second case, functional group is at position number 4. So second way of representing is the correct structure. Now the grammar to be followed while writing the IUPAC names. It is to be written as a one word with no gap in between. Whatever be the name, how long it may be, it is to be written as one word without any formal gap in between. And if two numbers come together, as you can see in the structures, the positions are 2 and 3 for the methyl groups. 2 and 3 are separated by comma. Number and number, they are separated by comma, and number and letters are separated by hyphens. In between 2 and 3 is comma. In between 3 and D, there is hyphen. Comma and hyphen, they cannot be replaced here. Number and number separated by comma, and number and alphabet separated by hyphen. And if there are two or more same type of the simple substituents, they should be prefixed as di, tri, tetra, etc. As in this case, the number of methyl groups, it's being represented as dimethyl in the first case, trimethyl in the second case. Now coming to the simpler compounds, a single line means two terminals are there, two carbon atoms it is representing. It is eth plus ane, root word is eth, plus one suffix, primary suffix. It is eth plus ane coming to ethane. Only two parts are there in this name. Similarly, in the second case, it is prop plus ane, propane, but plus ane, butane. And if we consider now these unsaturated compounds, in the first case, it's a chain with three carbon atoms. That means the root word is prop, plus a double bond is there. Primary suffix is ene. The name come out to be propene. As a double bond should get the lower number, we'll number it from right side, and double bond will definitely be at position number 1. So I have written here two options. Should it be written as propene, or should it be written as prop 1ene? Do we need to mention the position number 1 in this case? Similarly, look at the second structure. In the second structure, it's a chain of 4 carbon atoms with one double bond. A chain of 4 carbon atoms means the root word is but. For double bond, the primary suffix is ene. So but plus ene, it come out to be butene. And as a double bond to be get the lower position, that is to be numbered from the extreme right hand side. The double bond will be between 1 and 2, and number 1 is given to the double bond. And in the second structure also, two options are given here. Should it be written as butene or but1ene? Similarly, another isomer of the second structure, third is the isomer of the second. In that case, the double bond is at position number 2. And should it be written as butene or but2ene? So you have three structures here with two options each. Should it be propene or prop1ene, butene or but1ene, and then butene or but2ene? The clue is already there on the slide. Anyone with the answer? Yes, any answer? The clue is already there on the slide. So see here the answer. In the first case, 1 is not to be mentioned, while in the second case, 1 must be mentioned. अगर प्रोपीन में 1 लिख दिया then it is not acceptable. ब्यूटीन में 1 नहीं लिखा then it is not acceptable. Why is it so? Because in propene there is only one possibility. There is no possibility for prop 2ene. There is no such structure in which propene, the double bond, can be at position number 2. So if there is no other possibility, then 1 need not to be mentioned. But in case of butene, as you can see here, two possibilities are there. Double bond can be at position number 1. Double bond can be at position number 2. So we need to mention whether it is present at position number 1 or at position number 2. So it is but plus ene, but1ene. See the difference in the first and the second structure. Only the functional group has been added. If we compare the first and second structure, the difference lies with OH only. In the first case, numbering is from right to left, and in the second case, the numbering is from left to right. Because in the first case, only double bond is there, and double bond to be get the lower position, so numbering is done from the right side. In the second case, there is double bond as well as functional group, and in the preference order for numbering, functional group is preferred over double bond. Functional group should get the lower number. So in the second case, numbering is done from the left side, from where OH will get position number 2. If we number it from the right side, then OH will be at position number 3, which is not acceptable. So in the first case, ene is at position number 1. In the second case, ene is at position number 2. Position number 3, sorry. And here also you can see I have highlighted the E word here. Why E has been highlighted here? Because when we will write the complete name, ene plus ol, E of ene must be omitted. So it is but 3 ene, 2 ol, and it is ene is without E. In the first case, when it is at the terminal position, it is with E. In the second case, it is without E. So here we have the structure. Now, while writing the name, never ever go with full name as such. First split into the different parts. As in this case, if we go for the chain of carbon atoms, say starting with the numbering from the left side, 1, 2, 3, 4, 5. At position number 5, you can see there are 2 routes. From position number 5, we can go to position number 6 or 7. Or from position number 5, we can come downward towards 6 only. There are 2 routes. And out of these 2 routes, which is to be followed, again, it is on the preference order. In the first route, that is 6 and 7, we get the longer chain of 7 carbon atoms. But if we go downward towards 6, then we get the double bond. So double bond must be the part of the parent chain as far as possible. So we'll select the shorter chain or to include that double bond in the parent chain. The chain of 7 carbon atoms is ruled out here because the double bond will be out of the parent chain. So in this case, the root word is hex for 6 carbon atoms. And the other position 6 and 7 are now the substituents. And a substituent with 2 carbon atoms, it is to be written in the prefix as ethyl. Primary suffix for the presence of the double bond is ene. Secondary suffix for the functional group ol, it is for alcoholic OH, it is ol. And so combining all the parts, starting with root word hex plus ene plus ol in the prefix ethyl, and then mentioning all the positions, the full name come out to be 5-ethyl hex 5-ene 2-ol. So again, a question for you. Can you try to write your name in the IUPAC system? Can you try to write your name in IUPAC system? This is going to be very interesting for the students. Okay, I modified the question. Write IUPAC name of the structures depicted by the alphabets of your name. And see the answer. Suppose one is to write Sonal in the IUPAC system. SONAL. This is how the alphabets are to be written. First alphabet S. You see this is a chain of 6 carbon atoms. And as it is a chain of 6 carbon atoms, it is written as hexane. The second alphabet is O. It is a ring of 4 carbon atoms. For 4 carbon atoms, it is but plus ane and prefix is cyclo. It is written as cyclobutane. The third alphabet, that is N, is a chain of 4 carbon atoms, which is written as butane. The fifth alphabet A, it's a triangle. Triangle here means it's a cyclopropane. And prefix to cyclopropane are 2-methyl groups at position number 1 and 2. It is 1,2-dimethyl cyclopropane. And the last alphabet L, it's a chain of 3 carbon atoms, which is written as propane. So this is going to be very interesting for the students also. We can share the ABC in the IUPAC system with the students. Here you can see the ABC. If it is written like this, we can write the IUPAC names for all these alphabets. Now, as sir has already said, that we need to change the level of the questions. In this case, the different type of questions which can be asked. One is simply the structure is given and write down the name. Vice versa, the name is given and draw the structure. And this is going to be another level of the question, that how to write the correct IUPAC name from the given wrong name. It is admitted that the name given is wrong, but from that wrong name, we have to find out its correct name. And what is to be done in that case? Again, break that name into the different parts. As in the given name, which is 2-ethyl 4,4-dimethyl pentane, the root word, it's from pentane, the root word is pent. And the root word pent means first we'll draw a straight chain of 5 carbon atoms. As the suffix is ane, suffix ane indicates that all carbon-carbon bonds are the single bonds. Next suffix to ane, it is not there. That means in the given compound, there is no functional group. Infix cyclo is not there, means it's going to be a straight chain compound. And prefix to that are 2-ethyl 4,4-dimethyl. That means the substituents present are ethyl, methyl, and another methyl. So we have broken here this name into the different parts. The root word pent, primary suffix is ane, secondary suffix none, and prefix or substituents are ethyl, methyl, and methyl. So first what we are to do? For the starting again with the root word. For root word pent, we'll take a chain of 5 carbon atoms. Then, as all are the single bonds, in that chain of 5 carbon atoms, all single bonds as it is ane. Then number it from 1 to 5, either way, maybe from right to left or left to right, as I have numbered it from left to right. 5 carbon atoms are now labeled. At position number 2, according to the wrong name given, at position number 2, there is ethyl. And at position number 4, 2 methyl groups are there. One methyl group is shown upward, another methyl group is shown downward, and these substituents are shown here in yellow color. At position number 2, ethyl, and at position number 4, there are 2 methyl groups. Now we are to review this structure again. Is this really a chain of 5 carbon atoms? If we renumber this chain, wherever it is written number 5, if we take this as number 1, start from this number 1, number 4 will become number 2, 3 will remain 3, and then 2 will become 4. Right now, where it is written 2, it will become 4. And if we see this position, again 2 roots are there. On one root, there is 1 carbon which is labeled as 1. On the other root, there are 2 carbon atoms in yellow. So at position number 2, there are 2 roots, there is bifurcation, and we will go towards a more preferred path. Agar double bond hota, so we would have gone to that side where double bond is there. But in this case, as single bonds are there, so we will go to the longer chain side. And now this is no more a chain of 5 carbon atoms. Now the chain length has increased. The position of the locants is also changed. The locants are 2, 4, 4 from one side, but from the other side, there will be 2, 2, 4. 2, 2, 4 is preferred over 2, 4, 4. And here it is a chain of 6 carbon atoms. It's not a chain of 5 carbon atoms. Root word is hex plus ane. And in the prefix, now the substituents are three methyl groups. One methyl group at position number 2, second methyl at position number 2, and third methyl at position number 4. And finally, this name is 2,2,4 trimethylhexane. So we can follow the different level of questions. Structure is given, write the IUPAC name. Vice versa, IUPAC name is given, draw the structure, or such incorrect names are given. From these incorrect names, draw the structure, review the structure again, and see the name is entirely different. The chain of 5 carbon atoms is actually the chain of 6 carbon atoms here. And one more point we noted here, the ethyl as a substituent cannot be at position number 2 to an alkane, because ethyl at position number 2, that means from the other side it will increase the number of carbon atoms. That's all for the day. Any questions from your side? Thank you so much. Any questions?